Hello, everyone. I know this is hard to believe, but we only have 6 sections, counting this week's, left in this course. And this week's is section 6.1, Law of Signs, one of this week's, I should say. So, first of all, let's suppose we have a triangle. And with this particular triangle, this is angle alpha, beta, gamma. And this is our drawing here of our triangle. So, the law of signs is very rarely do we do proofs, but I like this proof. It's pretty clean and easy for you to see in an online environment, so I'm going to do this proof for you. It's very easy to derive based on right angle properties. Now notice, none of these are right angles. These are all acute angles, meaning they're less than 90 degrees. Remember, acute, less than 90, obtuse, between 90 and 180. Okay, so this is these are all acute angles, but we can use our right triangles to help solve this problem, and I'll show you how here in just a moment. So first of all, we use the fact that the sine of 180 degrees minus x equals sine x. Now, your first thought will be, how is that, Mr. Francis? Well, if you do your difference identity for sine, you will get that the sine of 180 minus x is the same thing as sine x. So because of that, we can refer to this triangle, and we don't have to worry about this degree measure because it's going to equal to sine x. So watch what I'm going to do here. I'm going to drop a height or an altitude. We're going to call that h. And make this into two right triangles. And I'm going to drop one other one because I want to be able to solve for alpha and beta. I'm going to drop one other altitude right here. Okay. This would allow me to solve for alpha, beta, and gamma by dropping the other altitude. Now we're going to focus right now just on this green one here. Okay, just on the green one. And so we have two right triangles. So what would the sine of alpha equal? What would the sine of alpha equal? Well, the sine of alpha, right here being alpha, the sine of alpha, if you're thinking of this is your new triangle you're looking at here. Okay, you've got alpha, h, and beta. Sine is opposite over hypotenuse, so that's going to be h over b. And I'm going to change colors because that color is really bothering me. Okay, so look at our other triangle. We can also figure out what the sine of beta is. Okay, if you look at this triangle, the sine of beta, sine is still opposite over hypotenuse, so that's going to be h over a. Now, if we solve both of these for h, because that's what they have in common, we have h equals b sine alpha, and we have h equals a sine beta. Now, h equals both of these, so because of that, our rules of inference tell us that we can say b sine alpha is equal to a sine beta. Now, here's what I'm going to do. I'm going to divide both sides by AB. And so the b's cancel, so that's going to be the sine of alpha all over A equals the sine of beta all over B. Now this particular proportion that you see here works for C and gamma as well. And so what we actually get here, the sine of gamma is to side C. So, and let me write that. I don't want you to get confused. Let me write that as B. Okay, so this right here, this is our law of sines. And what it says is we have a, in any triangle, the ratio of the sine of an angle to its opposite side is the same as the ratio of the sine of either of the other angles in its opposite side. And that's important for you to realize because our triangle, notice, gamma, C is the opposite side. Alpha, A is the opposite side. Beta, B is the opposite side. Memorize that triangle. Memorize that triangle. That's that relationship that those play to each other, being opposite sides, will be very key to you being able to get these problems right. Now, the law of sines are going to be used to solve triangles. Now, in section 6.2, we'll talk about something called the law of cosines, which will also be used to solve triangles. But for now, we're going to use law of sines. And law of sines can solve triangles in two ways. If you have two angles in any side, so in other words, an angle, side, angle, or an angle, angle, side. So if you have two angles in any side, law of sines can be used. Or if you have two sides and an angle opposite one of them. Let me say that again. If you have two sides and an angle opposite one of them, law of sines can be used to solve that as well. Now, these are our three cases that we will have. These are our three cases that we will have. And with these particular cases, we will we'll have varying problems. Now, side angle a lot of times is just referred to as the ambiguous case. Because with side angle, there are multiple ways that we can solve those problems, okay, given what information you're given. Okay, so we will look more at that here in just a moment. Alright, so let's, first of all, let's review something a second. What do all the angles of a triangle add to give you what degree? Hopefully you're saying 180 degrees. Because as you're solving these, remember, a triangle has to give you 180 degrees. So all of these angles have to be between 0 and 180. Okay? Because if you start getting bigger than 180, then you don't have a triangle. Okay, so keep that in mind. Just a little logic to use with this, okay? So this has been the proof of the law of sines. On the next video, we're actually going to start working on using this formula and applying it to these examples, okay? See you in the next video.